Training the generator and the discriminator will involve a kind of two-step training loop. The discriminator alternates between training on real data and fake data, so its training process should follow these steps. First, compute the discriminator loss on real training images. We'll use our real loss function to help with this. And when we train the discriminator, the true labels should be smoothed. Then you'll generate fake images and compute the discriminator loss on these fake generated images, similar to above, only using our fake loss function to help compute the loss here. Finally, you'll add up the real and fake loss components to get the total discriminator loss, and then you can perform backpropagation and an optimization step to update the weights of the discriminator. Next, training the generator. This should be a little simpler. The generator only cares about how the discriminator responds to its fake generated images. In fact, its goal is to trick the discriminator and get it to classify this fake generated data as real. So to train the generator, you'll start by generating some fake images, and then you'll compute the discriminator loss on these fake images. Only this time, you'll use flipped labels, or our real loss function, because the generator wants the discriminator to classify its images as real. And you won't need to use any label smoothing in this case. Then, with this generator loss, you can perform backpropagation and an optimization step as usual. Alright, so in this cell, I've started the training loop for you and commented some instructions. This will loop over our training data for some specified number of epochs, and I recommend at least 40 for some reasonable outputs. Then I have some code to keep track of the generator and discriminator losses, and also record some generated fake data as I train. So I'm setting the models to their training mode, and entering this epoch training loop. Then I'm getting our training data batches at a time. In here, I'm getting the batch size of our input image data, and here's an important step. I'm actually rescaling the input images, which are normalized to pixel values from 0 to 1, to be in a range of -1 to 1. The reason this is important is because our generator outputs have been scaled to be values between -1 and 1 with a tanh function, and I want these to be comparable to these real pixel values. So this is an important rescaling step. And, to move from a range from 0 to 1 to -1 to 1, we can just multiply 0 to 1 values by 2 to get a range of 0 to 2, and then subtract 1 to get a range of -1 to 1. Okay, so then in this batch loop, I have two big marked sections. First for training the discriminator, and second for training the generator. The discriminator will be trained on real and fake images, so you'll calculate two losses at each of these steps and sum them to get a total loss and perform backpropagation. The only code I'm providing here is showing you how to generate these fake images. So first, I'm generating a latent vector z, using values taken from a uniform distribution with values between -1 and 1. So these are random values in this range, and I'm making those batch size number of rows by z size or 100 in length. Then I'm converting these to be float tensors that can be passed to a generator. Our generator G can then take this z as input and generate some fake image vectors as output. And I'm just giving you one example for how to do this, and later on in training the generator, you'll be asked to generate some more of these images, and you can type out the same fake image creation code there. I'm leaving most of this for you to fill out, and at the end of the loop, I also have some code for printing out loss statistics and saving some sample generated data. This means that as we train, and after each epoch, we'll be recording the discriminator and generator loss, as well as saving some fake generated samples. So try to complete this training loop, and if you've done it correctly, this notebook will be complete, and you can proceed with generating sample data. Next, I'll show you my training process and some examples of this generated data.